Hello, class. This will be the last of recorded lectures on section 7.1, which deals with z-scores. And so we're going to use technology now to do these calculations. I will demonstrate the calculations using the spreadsheet and present the presentation data using the calculator so you can kind of see the difference between the two. The first thing we're going to do is calculate a z-score given a certain area or probability underneath the curve. And again, we have three options. And so option number one is this idea of finding the z-score given a certain area less than. And that's the most straightforward one, right? You could read it right off the table. You would just look for 0.26 in the table to find the z-score, or again, using the technology. And so if we go to the spreadsheet, whoops, I wanted to show you one thing more. So these are the two functions we're going to use on the spreadsheet. It's called norm.s.inv is the first one. And that given a probability or the area, it's going to come back as z-score. And it always gives you the z-score less than. And so you always have to think about it just like the table. And what does the calculator? It's inv.norm, which gives you the exact same thing. So the first one, if we pull up, let's play with it a little bit. We get more functions and then norm.s.inv, and you type in 0.26 and you get that z-score. And so whatever you want to round to, you round to. It looks like in the presentation they rounded to 2 decimal points, but you can see that your calculator will give you a boatload of decimals as well. So that is less than. So what do we do if you're asked the question, what is greater than? Well, remember, if you're given greater than, in this case it's 68%, what is the total? Remember, the total is 1. So the one that's less than is 1 minus that number. So you can get your calculator out like they did here and get 0.32, or you don't need no stinking calculator here, and you can let the spreadsheet do the calculation for you. So when you do this, more functions. So you could just do the 1 minus, 1 minus 0.68, and it'll do the calculations for you. And you could see that you also get the z-score of minus 0.467, et cetera, et cetera. And so you see that they round to 2 decimal points again, and you could use the spreadsheet or do the rounding yourself. So here's the tricky one. And this one is tricky because you're looking in between the two. And before we do that, I just want to show you this on the whiteboard to make sure, because this we're going to be using quite a bit as well. So if you're thinking about it, you want 95%, right? So inside here is 0.95. So remember what the symmetry idea is you want this z-score here, and that I'll call that z1, and you want the, well, the presentation calls that z2 and this z1. So what you really want to think about is what are the areas here and what is the area, and I'll put this in blue down here. Well, first of all, because of the symmetry aspect, both of these are the same. So if you think about it, you want to go 1.0.95, and that gives you 0.05. And half of the area is here, and the other half is here. So then you divide by 2, and you get this as 0.025, and this is 0.025. So how do you get the first z-score, z1? Well, that one's easy because the area less than is, once you figure that out, is 0.025. So we go back to the spreadsheet and do more functions, bring that in, and if you type in 0.025, you see you get minus 1.95999. So z-score really close to -2, right? And our empirical rule gives us 95 is plus or minus 2 standard deviations. You could see it ends up being minus 1.96 is typically what you round it to. So if you went back to that presentation, you could see we get z-score of minus 1.96. But how do we get the top one? Well, that one's a little tricky because to get the top one, you want all this here. And so that would be 1 minus 0.025 for the area that you put into our z-score here. And so when you use the spreadsheet in this calculation, you get, and again, I'll just let it do the math, 1 minus 0.025. And you can see you get the same one, but the positive. And so this one here would be plus 1.96, as we illustrated again in the PowerPoint presentation. So the next thing we're going to do is the opposite. Given a z-score, what would be the area probability calculations? And we'll do all three of those again like we did in the table. And the calculation for the spreadsheet is norm.s.dist. So this would be the opposite. And it has two inputs, the z-score, which will be given, or you have to calculate. And the last one is cumulative. And this one's kind of weird. I wish they would take this out, and they added this when they upgraded the spreadsheet. I don't know why. But the idea of cumulative, this must always be true. And always be true is the less than. Because this is a continuous distribution, the false doesn't make any sense because the area is always going to be 0 for a single point. And so z equals an x value does not make any sense. So never put false in with regards to that. So let's do this calculation. And again, here is using the calculator, and I'll do the same thing using the spreadsheet. And so they have a norm.cdf for that calculation. And so when we do this, here is the calculation. What is the area given less than, right? This is less than, if the z-score is 1.26. So if you do this calculation, it would be more functions and then norm.s.dist. And you see we have 2. So that would be 1.26. And this is always true. I wish they would just get rid of that, but they don't. And so you could see that the area is almost 90%, right? 0.896. And so if you use your calculator, you see you get the same thing. And typically you round this to 4 decimals because the z-score tables typically give it to you in 4 decimals. So hopefully the homework will do that as well. Here we have an example of to the right, given a z-score of minus 0.58. So remember, when you calculate the area to the right, it's 1 minus the area to the left. So here, when you do the calculation on the spreadsheet, the way I like to do it is to the right is 1 and then minus. And then if you bring up that formula, the z-score, what was the z-score? I forgot already. Minus 0.58. Minus 0.58. And remember, this is always true. And if you let it do that calculation, you can see you get 0.719 with regards to that. And you can see you get 0.719 with your calculator as well. So the good news is the exact same answers moving forward. The last one is what do you do in between? So this is an example of 2 z-scores. And so basically what you want to do is you take the biggest z-score, just like we did in the table, and subtract it from the smaller z-scores. And that'll give you the area between those two. And so let me show you how that works. So this would be equals. And so if you put the bigger one first, and so I wrote this down this time. That was 0.42 and true always. Okay, and that's the first one. So if you go back up here and just hit subtract or the minus sign and put the next one in here. And that one would be minus 1.42 and true. And you do the subtraction, you can see you get about 58.5%. And again, going to here, you see you get the exact same number with regard to that. So the next thing I'd like to do is I'm going to go to the ALEKS and show you how to do one of the problems on ALEKS using the spreadsheet. So I just randomly picked a problem here, and this one says, find the area underneath the standard normal curve given these z values and round everything to 4 decimals. And it says use the TI-84 calculator here. Don't have to use your calculator. You really have 3 options. You could use the table, and the table will give you a perfectly fine answer. And the good news is everything is 4 decimal points, just like I thought, because the tables are rounded to 4 decimal points. I'm going to show you how to do these calculations using the spreadsheet. The first one says, find the area underneath the standard normal curve that lies between these two z. And so I'm just going to write these down at z equals minus 2.27, and then z equals minus 0 or plus 0.36. So when you find in between, you want to take the big one and subtract it from the small one. So let's go to the spreadsheet here and do this calculation. So it would be equals more functions. And so it looks like 0.26 or 36 for this one, and true. And so that would be the first one. And let me show you a little different way so you can see both the values. So when you go over here and you do the second one, this one would be the smaller one, and that looks like that would be a z-score of 2.27 and true. And this should be a pretty small number, right? Yeah, and there it is. So now you want to subtract the 2. And so let's do that here. So you would do equals big number minus the small number. So you could do it in steps like I showed you in the other one. You could do it all in one cell as well. And so if you wanted to round this, let the machine do the rounding. And so you would go to format cells, numbers, and do 4 decimal places. So you can see it rounds it to 0.6290. So one more example here. Here's an example. Use your calculator again, but again, you could use the spreadsheet or you could use the tables as well to do this calculation. Now this one says a z-score, which is to the right, 0.36. And here you want a z-score with 2 decimal points. So we go to the spreadsheet, and this is the other function. So this would be the INV function, and the probability is always to the left. So this would be 1 minus 0.36. And you can see you get a z-score of 0.35, blah, blah, blah. And remember, you could, I already forgot what the decimal, so it says 2 decimal places. So you could, again, right click and format cells. And if you go to number here, you already have 2 decimals, and that would be 0.36. So I just thought I'd type it in, see what I get, and I did 0.36, and then it says an alternate is 0.36. So, but it does give you credit if you don't put the 0 in front. So I sympathize with you guys. This thing is very picky. So that ends the recorded lectures for section 7.1. Just in summary, we talked about calculating of z-scores given a mean and standard deviation. We talked about how to calculate using tables, definitely demonstrated how to use the spreadsheet, and you could read the book and the slides that are uploaded to get a better feel on how to use the calculator.